All right, so 3.1. It is very, very interesting. A lot of it is reading, reading, reading. Do you all have the set of notes? I figured it. But we have them. That is not a problem. So we're going to wrap up this chapter with something fun. Well, you never really seen it before. But it's interesting. It's interesting. It's pretty good. It's not bad at all. So it's reading, more reading again, but I think it's, you can really comprehend it pretty good. All right, so in 3.1, the first thing is a mathematical statement. So you are doing statements in math. So here are just the statements that it's just saying it's a complete sentence, just like in English, a complete sentence. A complete sentence that asserts a claim, which is either true or false, but not both at the same time. So it's going to be true or false, but it's not going to be both of them. All right, so here are just some examples of some sentences. So it says determine if the following sentences are statements. A, it is raining outside. B, beaches are the most beautiful place to vacation. C, today is Monday. D, today is Monday and tomorrow is Friday. E, I lie all the time. Okay, so what can you say are just really statements? Um, can you say A is a statement? It's raining outside. It's a statement. But now B, when you say beaches are the most beautiful place to vacation, that is more of an opinion because some people may like mountains. So that would be your opinion. I'm just gonna put O for opinion. And this would be like S for a statement. And today is Monday. Couldn't that be a statement? This is just a statement. Because remember we said the statements can be either true or false, but not at the same time. All right, so D, today is Monday and tomorrow is Friday. That's a statement as well. And then and the last one, I lie all the time. That is something called a paradox. It's not really what we're required to go over, but it's a paradox it contradicts itself and has no truth value. You can't verify it. All right, it has no truth value. So that's just what we call a paradox. So we're just dealing with statements and we're going to just change the statements around. All right, so the second part. Determine if the following sentences are mathematical statements. All right, so M. Aretha Franklin was the first woman inducted into the Rock and Roll Hall of Fame. N. A physician has the most stressful job in the world. So can we say that? Well, M. That would be a statement. A physician has the most stressful job in the world. That can we really prove that? All right, so that would not be a statement because that's more of an opinion. Because some people may think that a rocket scientist has the most stressful job in the world. And any number multiplied by 0 equals 1. Would that make sense to you? Any number multiplied by 0 equals 1. Is that even true? No, it's not. It's just a statement, but yeah, you can't really prove that. All right, so just statements. These are just examples of statements. So negation. Negation of a statement is a logical opposite. So this is the symbol when you're dealing with negation. It's just the opposite. And so it's not a negative sign. They're just going to make it like a little squiggly line. So now you can look at, here are the different symbols. When you're talking about not P, this is doing the opposite of the statement. You have the squiggly line P or like the negative of this bar. But if we're doing not, we're most likely going to see this symbol here, the squiggly line P. That means not P. So it is not the case that P. So we're going to talk about in just a second. You're just going to do the opposite of it. Negation is going to be the opposite of whatever statement you see. So now we're going to negate the following sentences, just doing the opposite. So A is Melanie is wearing a raincoat. So if we negated that, we will say Melanie is not wearing a raincoat. So I'm not going to rewrite that whole sentence again. I'm just going to put not there. Just not. And so literally on your test, you'll be asked questions like that. Can you write the negation of these sentences? So that's why I said this section is not bad. It's just doing what the words say. All right, so B, The door is not closed. So if you're going to do the negation of it, you say the door is closed. So you just take that out. The door is closed. Just the opposite. So now you have C. Some of the tourists brought raincoats. No, oops, I'm sorry. None of the tourists brought raincoats. So the negation would be some of the tourists brought raincoats. But now your question may be like, what if you changed and you put all of the tourists bought raincoats? Would I count it wrong? No. So that's the good thing about this. If you're, as long as it says the opposite, if what's the opposite of none, if you put all or even some, that would be negating this. So if you put some or all, that's okay with me. I'm not gonna count it wrong. So if you just change your sentence to say some of the tourists brought raincoats, that's fine. All right, so D, I run less than car. So if I run less than car, the opposite would be I do not run less than car. So long as your words just say the opposite, then that works. All right, and the next one is just a skill check. Some of the students completed their assignments, and here's the answers already here for you. The opposite of some of the students completed their assignments would be none of the students completed their assignments. So that's all you have to write there. So the first thing we did was identify statements. They can't be both true and false, just statements. And next, we're dealing with definitions of compound statements. So now we're going to say compound statements. They're going to be combined with and, or implies. These are the words we're going to put these together with the statements. We're just going to put and in the middle, or implies. So A and B are statements with the compound is a compound statement called a conjunction. The symbol like this, I call it like an A without the line in the middle, is used to represent conjunction. So this is for the word and that's what's on the cheat sheet I gave you. So you probably didn't recognize some of those, but today you really will recognize all of them. So this we're going to put and. So first we did just the statements, then we did the negation. So now we're going to do the conjunction. And the first word we're going to use is and when we put things together. So it's no math computation involved, just and. And so try to remember that like an A without the bar in the middle. So consider the following statements. A, snow is falling. B, the sun is shining. So now we're going to write the conjunctive, compound statements using the logic symbols. So let me give the answer for you. If this is A and this is B, and we want to put these together, and we want to say and, I want to see, is it on the next slide? Yeah, nope, I have to do it. So if it's and we want to put these together, and I want to use symbols, and the answer is C. Snow is falling and the sun is shining. Snow is falling and the sun is shining. Then you would just write A conjunction B. These are the words. This is the word part with just C. And A conjunction B, this would be the symbol part. So we will give you a statement and say, can you write it in symbolic form? So when you write in symbolic form, and where did I get A and B from? That was at the beginning of each of the statements. So they'll give you the statements, and then they put and right here, so you replace and with this symbol. So now D, the sun is shining and snow is not falling. So the sun is shining, that's A, right? Oh, no, the sun is shining, that would be B. So you would write B. Is that okay? Because you have to write them in the order that you see them. The sun is shining, that's B. And then it has the word and. So I'm going to write this symbol. Snow is not falling. So this says snow is falling. So how do I write the opposite that is not falling? Squiggly line A. So they'll give us two statements. So that's what we're trying to get to. This is the fun part. So you know two statements, and then how do you put symbols with it to state the words that they have in symbolic form? That's what we're doing. So does that make sense to you? Yep, not too hard. Nothing mathematically to do. All right, so now we're going to deal with or. So you have that on your sheet too. If or, I call it like if you can't write a or correctly, just write a or because it has or and like some people write cricket R's. I don't know if you just have bad handwriting, but that just helped me. If I know this is and, then I know the other one is or. So I was trying to do something just to help people know which one is which, and it's on your sheet too. So if it's a V is or, so just you know one, you know the other. So now we're going to do these words and we're going to combine them with the word or. So it's going to be real hard. So here's the first statement P. He will go to the movies tonight. Q. He will stay home to give the dog a bath tonight. So now we're going to write the statements using our symbols. R. He will go to the movies tonight, or he will stay home to give the dog a bath. So he will go to the movies tonight. That is P, right? And then or we have the little V, and then he will stay home to give the dog a bath tonight. So they didn't change anything, did they? So that would be P and Q. And I think this one is the one that's written on the next page, but we'll do it. It's fine. Okay, so C, he will not go to the movies tonight. So what are they going to do to P? Negate P. Oops. Be the squiggly line P. Or, as we have your V, he will not stay home to give the dog a bath tonight. So we'll do squiggly line Q. Because they negated both of those and then they used the or. So students usually like these. And I think this is answered on your page. It is. I knew one was and one wasn't. So that's that. There. That's the next page. So mathematical logic always use the inclusive or, meaning one or the other or both, or the inclusive or is represented by the symbol with the V. That's the next helpful hint that's written. But any questions so far? All right, so now we're going to conditional. Nothing to compute again, it's conditional. So now we have the statements if, then. So if A, then B is a compound statement called a conditional. The symbol, it's like an arrow, is used to represent a conditional statement. So this is going to be our friend the rest of the day. So let's see what they're talking about. So all this stuff is if then. So they can say P implies Q, or I can say if P then Q. I would say this is what we'll probably use. If P then Q. If then. These are just other things they could say. P is sufficient for Q. Q is necessary for P. P will lead to Q. Q if P. P a Q whenever P. P only if Q. We probably won't use all those words. We're just gonna do probably if then, because that's just not really our common talk when we put things together. So we're gonna go with that. So just FYI. So now we're going to consider this and try not to look at this part of it. So S, the water temperature on Saturday is below 76.2 degrees Fahrenheit. T, you are allowed to wear a wetsuit in the triathlon. So write the following compound statements using the logic symbols. All right, so Q, if the water temperature on Saturday is below 76.2, wouldn't that just be S? Because that's just saying the water's just all this is the same, right? Then you are allowed to wear a wetsuit in a triathlon. So it's like a if then. So here's your answer. It's just restating. Then you are allowed to wear the wetsuit. It's like S, and then they have the double arrows to T. So it's like if then, because this is the S, the first part, then T is the second part. And it says if and then you just use this implied arrow. The first part implies the second part. and that's basically it. So it's just pointing out, it's saying if and then, so all you do is use this arrow. Now, if it negated any part of it, because it said, if it said the water temperature is not, the water temperature on Saturday is not below 76.2 degrees, then you would put a squiggly line in front of S. So it's just relating these two statements. It says if then, use that symbol. And I think I put that on your, no, you may want to add, it's at the bottom of the truth table, so. Oh, I just have if then it's one arrow. In the old book it had one arrow, but here we have two. Not arrows, but lines, I mean. I think that was the old book, and now we're doing this one. So it's just the arrows right here. So if then you have that symbol. All right. Too hard? Questions on that? So that's if then. So now we're gonna go to, well, I just said that one. I didn't know it was there. But if they said not, if you are not allowed to wear the wetsuit, so you're not allowed to wear the wetsuit in the triathlon if the water temperature on Saturday is not below. So therefore, they negated both of those. So you just do the negate and you squiggly line. So it's the same thing as before if they do the opposite. All right. So next, we are going to do this. All right, here's the symbol. This is the same thing, just doing a skill check. Make sure you understand what we're talking about. But these are shorter sentences, which is a whole lot better, right? All right, so the first one, A, I am hungry. B, I am tired. C, I am in college. So write the three compound statements symbolically. So how do we write I am hungry and tired? What would you use with A, B, and C? So I am hungry. That is, you want me to give y'all a second? Because I'll be talking a lot. Let's see if you can do 1, 2, and 3 using A, B, and C. Use your symbols, the and, or, and the negation symbols. So I am hungry and tired. So what would you use? You're putting A and B together. So what symbol would you use for and? Yes, I know. Yeah, just the up A thing, whatever. All right, because they did not negate anything, did they? So I am hungry or I am in college. So that would be which letters? And then you're going to use the, yeah, down arrow. All right, I am tired and not in college. Where they got these examples from? So I am tired. That would be B, right? And then it says, yep, squiggly line. C. We're about to say something. Is that good? It's not too bad, right? So you're not computing anything. It's just doing symbols and words. And it's just the and or the negation. That's all we did. And we did the implies, the conditional. So now we did the conditional. So now we have to do the biconditional. So let's see what they're talking about there. So that's what I'm saying. It seems like a whole lot for not a big concept. So biconditional is if and only if. All right, and this is a symbol you're going to use. So I know on your sheet you have this, but at the bottom I have this. So you need a two arrow. So the biconditional, this is what it. That was the old book. This is the new one. So we're going to use biconditional. That means first part, if and only if B. So we have some conditions to satisfy with the biconditional. So same words. See what we got going on. C. Octopuses have 3 hearts. D. The platypus does not have a stomach. I have no idea if that's true or false. I don't know. All right, so here we go. Let's we can Google. The platypus does not have a stomach if and only if octopuses have 3 hearts. They always give you something you have to think about. So we have if and only if. So what part is first? What are they doing here? All right, so they have the D. That's the platypus does not have a heart, and that's they didn't change anything for that with that one, did they? And then if and only if, that would be our little symbol, right? The double arrows. And octopus have 3 hearts. They didn't change anything, no. And I see on their other part it says that they put the C first. And with me, it's okay because they're interchangeable because it's if and only if. Because you'll see that on the next page. I think that's what it has. Yeah, C to D. We put the D first, but does not have a heart only if and only if octopuses have not. So I mean they wrote it backwards, but it would go see they're interchangeable if and only if both of them have to be true. See what I'm saying? The arrows will go back. So with me, I mean I don't see why I would not take the D first, even though they wrote it backward, from because that's what we're doing the other ones. Because if and only if they both have to be true for them both to work. That kind of makes sense. So that's why I will go both ways. All right, so the next part. Octopuses do not have 3 hearts. So you will put a squiggly line in front of C because that does not have 3 hearts. And then it says if and only if the platypus has a stomach. And that's going to be changing that one. Does not have a stomach. So we have to change this one. And so that would be the answer to that one. All right, questions, comments, conjectures. And that's 3.1. So 3.1 is the top part of that math fun fact sheets. You did the statements, you did the negation, you did the and the or. And that's all you're going to do. We're going to give you the symbols and then we're going to give you the words, can you give the symbols? Even if I gave you the symbols, can you produce the words? But they would have to give you, some words to use. So just going back and forth with just a negation. So not a hard concept, just something you probably just don't do every day. But it's not too bad. It's not too bad. All right, so now we're going to go to our truth tables, which will be very, very fun. And I'm going to minimize so we won't have that happen again. So truth tables are different, but they're very interesting. And if you know one concept, if I teach the one concept, but this is a different publisher, but when you get that one concept, you can do the whole thing. We're going to minimize all this. They do a lot of words but we're going to summarize it into something real quick. If it'll come up for us. Let's see. It didn't want to load this slide in the beginning for some reason. I don't know why it did. And I really need to write on it. I may have to do it from this. Let's see if this will work. Okay, it will. We'll do it this way. All right, so the truth tables. As we stated in section 3.1, mathematical logic deals in part of deciding the truth value of different types of segments. So some people use the truth tables. I heard for some of the electronic degrees, they said they did something similar to this. So for instance, consider the statement A and its negation and its negation. If we let A be the statement, today is Monday, then it is either true or false, depending on when you are reading this. Doesn't that make sense? Okay, so if A is true, then its negation will be false. However, if A is false, then its negation will be true. Interesting, right? So in other words, we're gonna just do our letters and be done with it. All right, so to help keep track of the different possible truth tables for the statement, we can construct a truth table. A truth table is a chart with rows and columns that systematically list out each possible combination of truth values. Once fully complete, the truth table reveals the conditions under which a statement is true and in which it is false, when it's true and false. One of the simplest truth tables is that of the negation we just discussed. So, for example, if they tell you this is true, then the negation of it will be false. If they tell you it's false, then the negation of it will be true. And so that's what we're going to do. We're going to go back and forth with these situations. It is just, hold on, it's not going to be a whole lot. At first, when I looked at it, I was like, ooh, this is a lot. But let's try to make it simple. All right, so I'm going to kind of go through these with that because I don't want to do a lot of words to confuse you. The conjunction, we just did the conjunction and. We're going to use that. And then there's a rule that we're going to use when we're doing the conjunction. It's also on your truth table, on that fun fact sheet, but I want to summarize it with this one. So basically, it's saying that if you have A and D, you're going to be given A and D. You don't have to create these. You're going to be given these two columns, but you're going to be given this column, and they may leave this last column blank, this last one right here. So what you have to do is see how this is the and symbol. On my sheet, I have the and symbol. It says and only true when both are true. So I'm going to write this fact on here to help you as we go along. So if you have an and symbol, and then you have, let me do this. If you have true, true, and you have the and symbol, then it's going to equal a true. So you don't have to worry about looking at anything else. So what do I mean by that? If you have two T's and this symbol is and, right? Then when they give you that problem, and this is and, but over here in the columns before, if you have two T's, then your answer is true. So you write that true right there, and everything else, you don't even have to look at it. It's going to be false. So you have to keep in your mind, if they give you the and symbol and you have two truths, then your answer is going to be true. So I even wrote, that's what I wrote there, I think. If it's and you have two truths, then your answer is the truth. And don't even worry about it. That's the truth. And I try to put words with it, but sometimes it's kind of confusing. It's like, if this is true and that is true, then the answer is true. But if you have a statement that's true and false or false and true, can it be true? No, it's like saying if I like red and I like how I can never think of, like today is Monday and tomorrow is Monday, then it has to be true. But if today is Monday and tomorrow is not Monday, can it be true at all? No. So it's kind of, let's start missing people. But basically, if something is true and something is true, then it's gonna be true. But if you got any kind of false in there, is it gonna be true? No, because of the word and. Because the word and. That's the whole situation. All right, so let me see if we're gonna get to the or. Now the next one is the or. And so what you have to remember about or is, put on this table. If you even have an or of any kind of situation, if it is the or, and then if you have two F's, if it's going to be false or false, then your overall answer is just a false. And that's the summary at the bottom. If it's or, both of them are false. But if you got any kind of true in there, because so look, when you have here, like this is a false and this is a false, then this is a false. But if you got any kind of true, like it may be true or it may be false, then yeah, there's a possibility it could be true. So all you gotta do if you're looking for anything like this, or if you have two F's, then it's F, and just mark everything else true. Don't even worry about it. Let's see. Oh. Okay, so now we have those thoughts in our mind, and or. So now let's see, can we get to some fun stuff? I think that they're gonna do conditional, then we'll put it together. All right, so we do have another conditional situation. So I like summary. So I also put that one there. So if you have implies, that's at the very bottom. That's a new one. So that is the if and then. So if you have this symbol, if then, I summarized it. Okay, so if you have a T and an F, if it's a true and a false, then it's going to be a false. So false only when P is true. So if you got the P, this will be the A. Only when this one is true and this is false, you're going to have a false. And just ignore everything else is going to be a true. All right, so this is the line right here. Only if, let's say today is Monday, tomorrow is not Monday, then hey, it's gonna be a false. If then, if today, and that makes sense. If today is Monday, then tomorrow is not Monday, then it has to be false. So it's a if then, and I'm horrible with creating those real world situations. But just know if it's TF, it's gonna be false, and everything else will be true. And we're gonna put it all together. So that's the third thing. It's only one more you got to know is that's the if then. So we're gonna bypass no the if and only if by conditional. So the shortcut with by conditional is if you have a true and a true, oops, then it's going to be a true. And if you have a false and a false, oops, it's going to be a true. So the shortcut for that one is also at the bottom. For the biconditional, if you have a true, true, or a false, false, the whole answer is going to be a true. So you have to remember those. So if you have a true, true, it's going to be a true. It's like a double case scenario. It's like a biconditional if only. If you have two F's, it's a true. If you have two T's, it's a true. But everything else, so if you have a combination of anything else, it's going to be a false. So it's true when you have the same value, and that's when you should. True when the same value. Oh, when you have the same value, I should have put that. When the values are the same, it's going to be true. All right, so I gave you all of that, and you're like, whew, what is she talking about? We have to construct all that stuff. We have to put all that together. So the next, this is just everything I did. I summarized all of this right here is the summary of those of what they will be. Opposite, and la la la. So now I'm gonna skip to, I guess I skipped all the way to on page 7. Make sure it's the same one. Of how we're gonna construct the truth table. So it goes in pieces, but let's see if we can go ahead and just do it in one. See if y'all understand it. So you'll be given the A and the B. I'm gonna construct all of the rest of your PowerPoints on this one page. So they're gonna give you the true and the false, and I'm gonna write that for you here. So we have a true, true, false, false, and then true, false, true, false. See, every one of them, they're going to give you different situations. And you have to figure it out. All right, so, but you're given A and B. That's going to be given. You have to figure that out. So now we have the and symbol. So what did I tell you about the and symbol? What do you have to remember? Right, so you're going to go look for two truths. So we're going to look for two truths, and that is going to be the first row, right? So if this is true and true, this is going to be true. And everything else is false. I'm not even going to look at it. And the thing about this is you're going to do one column at a time. One column at a time. And so now the next part would be, so you're done with this. So what did they add? This is the same thing as this, but they added the not in front of it. So what does negation mean? It's the opposite, right? So what's the opposite? I'm going to do the opposite of this column. So what's the opposite of true? False. And so all of these would be, that's that. So that's what I'm saying. We do a whole bunch of, a lot of that. So look on your last page. Does our answer match? under skill check 3.2.1. And that's it. So that's all you're doing. And so they're gonna put they may get to this page and put like A implies B. Oops. And then we have to do look for the TF, and then that will be that, or look for the implies. So we're gonna practice some. So you see, it's just gonna be giving you different situations, and you figure it out. All right. So here are the words. They have one words here. Let's talk through this one. Then we go to our other sheet. All right. So F. Arizona is the first state listed alphabetically. G. Albany is the capital of New York. So determine the truth value of the statement and then use table, we don't have that, to determine if the negation of F and G is true. And we don't have that table. But they're saying, all right, so look at F. Is F true or false? Is Arizona the first state listed alphabetically? No, because there's Alabama, some more, or even Alaska. So that would be false, right? So this will be our false statement. And just FYI, you have more of the truth tables. We won't give you statements. But I think I need to show you this just in case. So, all right, so that would be false. And then look at this. Albany is the capital of New York. Is that the truth? I think it is. Y'all Google it. It's not the capital of New York. Or you got the phone there, Google that. I mean, I think it must be. I think it is. Sure. Let's see. The capital of New York. All right, so that is true. All right, so there we go. All right, so that is true. So now they want to know this statement right here. So the opposite, if you do F and G, remember we said if it's and then it's true, we don't have that, right? Because if it's and, it has to be true and true for it to be true. So for just this right here, this will be false. And then what's the opposite of false? True. That's a lot of thinking right there. But that's what they do. That's what they do. So they got F and G. So F is false. That's where I got this from. This is false, and we proved that. And we said, okay, this is true. So we put them together with and. If you put a false together with the true, then that's automatically going to be a false. But then they want you to do the opposite of this false, which would be true. So that would be a good bonus if I put that on there. But so we're just going to do the truth tables. So the truth tables, I am going to start. They are plenty in your book and your homework, but I do have the review sheet, and I said, well, this would be good because they're larger. So I'm going to give this. I'm going to recreate it on the board so y'all can look at it, and so you see what we're talking about. Truth tables, because we only just did a little piece of one. Excuse me. So we want to do some longer ones so you'll see. So let's skip all the way. It's at the end. Oh, they're matching that, but let's do it from the beginning to number. Well, we can start with number 9. We can start with 9 because they're 9, 10, 11. We'll start with that one. Now I'll write it up here. Now it's matching, but we'll start and we'll do it, and then we'll just see which answer. I think that's easier. So I'll give you a second if you don't know what we're talking about. We're basically going to do. We're going to use the first 2 columns are the same, but we're going to see which one has the correct last 2 columns. All right, let's do this so we won't. So we make sure we count on the right page. All right, so we have squiggly line D. I'm not gonna copy any of these answers because we don't know which one is right. So if we want to do negate D, what would we have in this third column? Well, it would be the opposite of the D column. Can y'all see that? So the opposite of this D would be false. This would be true. This would be false. And this would be true. Am I not okay with that? Now, what it means for this, that means we're going to take the C column. And I'm going to highlight it. I'm a color person. If we highlight this column, that's what it means, C. And then we're going to use this column. And then, because it says the C and the D, right? So that's why it's only this one and this column I'm looking at. But I want to combine it with and. All right, I'm going to use a different color. So if I combine it with and, let's go back to our rule sheet. When it says and, it needs to have what? Two. If it's and, it has to have two truths, correct? So I'm going to look at my two highlights. I'm going to look for my two F's. And my two F's would be here, which would be true right there. So all I'm going to do is write true right here, and everything else will have to be false. So it seems like a lot explaining for these problems. So you only look at that. So the answer there would be FTF. Would it be B? Yes. I think that's it. So then you would choose, that's how you would choose your correct answer. All right, questions on that. How does that look? All right, let's see. The next truth table will be number 10. Let's look at that one. Now look at they are matching, but it just seems long. All right, so for this one, we have to prove this. Yeah, this is pretty long. Note to self, you do not need the long ones. Okay. All right, so we got this. So now that's the hard part. So let's do one column at a time. I'll even do a different color, blue. So, oh no, I gotta fill that one in. Shoot, hold on. That's a given too. You're giving all these. TFT, FT. Okay. So now we're gonna do opposite of P. So the only thing we're gonna do is look at this P column and change to the opposite. Do you agree? Are you okay with that? So this will be alt, yeah, all FF, and then this will be true, true, oh, true, true. All right, so that's that column. One column at a time. Done with that. All right, for the next one, you're going to compare P. I'm going to compare this column with the Q column. And then I'm going to use the word and. So if I'm going to use and, I need to have two T's for it to be a true. So I'm going to look at these two green highlights. Wherever I have two T's, that's what I'm going to put a true. So true right here. Oh, and then right here. And that's it. So now everything else will be what? False. Mm. So you do have to get the columns correct. Match up. All right, so now you have that column. So now what are we going to compare for the last column? Mm-hmm. So it'll be this one and this one. I should make it bigger. So I'm only going to look at the pink. But the deal with that is when I have that, the if then, so we look on our sheet, you need to have a TF and then it will be false. So the P is true and the Q is false. So if it's in that order, the first one has to be T and then F for it to be false. So you have to look backwards. So this has to be true and that has to be false in order for it to be false. So we have to look for a TF in this column for it to be false, right? So I'm looking for a TF, TF, TF. We'll just go for TF. No, right here. So this will be my only false. And that's it. And then all the others will have to be true. So you look for one condition and take them one by one, and then that's it. So I think that's B. And that's the only answer. Yes, that would be B. So you notice if you all don't need the long ones, right? I'm glad I did the long. I mean, it didn't take that long. It did. I mean, it's just more or less writing it down. All right. So 11, I'll let you do 11 by yourself. See how 11 goes. I made it out. I think it's matching. Or do y'all like I can just take it out where y'all can just fill it out? Isn't that a lot better? And you'll have your P, Q, and R, M in. And yeah, that's a lot easier than because I thought the matching would be better from previous years, but looking at this, I like doing it just straight. Yeah, than just this. Yeah, and I want to send your homework. You may be matching. I'm not sure. Mm. Yeah, but that's good. Now I want to match up your answers on the back. So do that one. Let me see if these all match up. All right, so you have this one. So you did the opposite of M. You put, what did you put in this column? Okay. All right, and so for the last column, you compared this column and you compared the end column. And what were you looking for when you were doing that? Because it has to imply. It needed to say what first, right? It needed to be there, not M. And it needed to say true, right, false, for it to be a false, right? So if that is true, then if it's true, then if, then for it to be a false. So we need to look for a T first, then an F. So that would only be this last one, right? So you have F here, and everything else would have to be true. So how did that go? They went. All right, so now the rest of these, one number got off some kind of way. But go ahead. This is like putting everything together. We've done all of the truth tables, I believe. I think it's two on the back. But I think the last two are truth tables. But for some reason, I guess the numbers got off. I'm going to tell you about the numbers. It's only one number that's off. But go through the beginning. Make sure you can remember about deductive, inductive reasoning. Do that, and we're going to go through these answers and make sure you're okay for the test.